What's up, everybody? Today we have special guest Sergey Teplyakov. He is one of my favorite author. He is a blogger. He has really cool book on design patterns in .NET. And this book for me is the best book written in the last 20 years. This is really cool book. You can find a lot of interesting stuff, not just design patterns, but also really design thinking, the architectural thinking, and also a lot of information about solar principles. Sergey Teplakov has more than 20 years in software development practice. He is also principal software engineer at Microsoft, and I'm really happy to meet Sergey today in our podcast. Thank you very much, Sergey, for participating in our podcast. And here you are. Please tell us about yourself.
Nice to meet you here, and thanks for inviting. I'm Sergey. I moved to the United States 10 years ago. Overall, I have 20 plus years of experience. My main areas of interest are like C# internals, .NET performance. That's the main key areas of interest right now. It's actually today's topic is about .NET performance, but it would be actually interesting at some point to talk about maybe design patterns and solid principles and how I've changed my mind a little bit after moving to the States, because I think that the way people think about them is slightly different based on the community and the country and whatnot. But yeah, I was working at Microsoft for 10 years. Most of that time I've spent at what's called One Engineering Systems team. So this is the team responsible for scalable tools for developers. So right now it's part of DevDiv development division. The main responsibility. So I was working on various build systems. So we have a scalable build system called Build Excel. It's open sourced for building Office and Windows. It's similar to Bazel. So essentially, the next gen build systems are like, it's actually quite interesting domain. It's kind of like pure functions, and some ideas from functional programming leaked there and used a lot. And then I've been doing a lot of distributed caching there. And almost a year ago, I moved to Azure Core, to Azure Physical Networking team. And there I've been mostly focusing on application performance and reliability. And I think I have quite a bit of stories to tell about .NET performance and how to deal with this, how to approach different problems.
We
That's
have tons of questions for you today,
yeah.
especially from the performance perspective. So, if you mind, I want to start from the first question. I'm really thinking about what people at Microsoft, especially in your team, are doing daily basis from the performance optimization perspective. So, can you please tell us about some interesting performance optimization you have done recently, especially at Microsoft?
Okay, when I joined the team, one of the first questions my manager asked me if how good I am and how familiar I am with profiling tools, because one of the key services that Azure Networking team provides was having some perf issues in terms of memory. I obviously cannot go into too many details, but the idea is that it's kind of a registry that it was taking like up to 400 gigs of memory. And it's a beefy machine. It's a kind of monolith-like architecture, which actually nothing wrong with that, absolutely, if it solves the problem. The idea was to cut the memory footprint and reduce the startup time of that application. And normally, if you just started looking into perf problems, the first thing that you need to do is you need to gather a lot of data. And luckily, we had like a ton of telemetry in terms of like overall memory footprint, like startup duration and whatnot. And then okay, so you have a problem that like we need to cut memory footprint by X. In this case, it was like relatively clear that we need to cut like about 100 gigs of memory footprint to do that. And this is a core service. An interesting observation for almost every perf enthusiast or perf expert will tell you that the perf problems are not spread equally in the code. There are like some very special type of problem when a perf kind of overhead is spread over the entire code base. So for instance, you have dynamic dispatch, and if you do this a lot for CPU intensive application, that will slow down your application gradually, and that's why probably in most cases for the same type of number crunching thing, C++ or native code will beat something like imperative code, but again, it's like with asterisks. So, and I was looking into memory footprint, and I found like a lot of interesting challenges that we had. So for instance, I blogged about that in my Dissecting the Code blog after that string interning was, I looked at one of the profilers that we have built in all the Azure services, that string interning was really, really expensive. And we had like 80 or 90% of time spent in lock contention. Like, wow, it's interesting. So I tried to remove this, and okay, so I got a huge perf boost for that. But that was intentional to reduce the memory footprint, because like string interning is a type of optimization that Java and C# and .NET have, that you can essentially deduplicate the strings that you have. So normally the runtime will do this for string literals. So if you have a string literal a.b or a constant, it'll be deduplicated. So if you have multiple constants with the same value in your application, that's gonna be one single instance. But you can do the same by calling string.intern to deduplicate the value, and then the argument will be discarded because you'll get a reference to a global instance. Which is good, but it means that it's a global table, meaning that once you go through that, it naturally will acquire some form of global synchronization. And I checked that, and wow, it was expensive, but it was helpful, because for that type of application, it was saving like probably like a few % of memory, but we're talking about like 40 gigs of memory and whatnot. So in this case, to fix perf, I need to remove this, or to find another way to do the same thing. But or I need to cut the memory footprint even more than that to allow that. So during that thing, what I tried is like, let me try a simple concurrent dictionary for that. And I was looking and just that was had a surprising impact. So you might think that a built-in technology like string interning in the CLR should be way more efficient than handcrafted implementation with like 4 lines of code, but it's actually not. It's interesting that string interning is implemented in native code, and probably it was implemented like, I don't know, in 1999 or something. Maybe it was changed after that. I don't have any ideas about that. But my concurrent dictionary implementation that was just try get or update method was probably like 5, 7, or 10x more performant. So and wow, okay, cool. So we can keep this implementation, but we can actually drastically improve the performance of this piece. And then it was interesting where you can find some memory optimization to reduce the memory footprint. For instance, it's kind of, the application was running on .NET Core or on full framework, and probably we can touch about .NET Core versus full framework in terms of perf. But overall, for full framework specifically, there are some like built-in things that are not as efficient as they might be. One of them is concurrent bag. So concurrent bag is an interesting data structure that you can use for if you don't need anything like order, but you have multiple threads putting stuff into this bag and multiple threads reading this thing without any ordering guarantee. Unlike concurrent stack or concurrent queue that have a queue or stack semantics, concurrent bag doesn't have any semantics. And you might think that since it doesn't have any semantics, it should be the most efficient version of concurrent collection. Actually, it's not, especially for .NET full framework. it actually has a quite horrible performance. In like pre.NET 4 era, it was like absolutely abysmal. It was like really bad. Then it was fixed, but it has its own quirks, and just by changing that, reduce like the memory footprint by like 5%. And then gradually looking into memory layout, what can be optimized. So for instance, one optimization that you can go into is, especially if you're on a full framework, in .NET Core, there are like some very nice built-in building blocks right now that you have a hash set, for instance, but in 99% cases, you have only a single value. Okay, cool. So, but the hash set has a quite non-negligible overhead just for holding one value. So one optimization that I've added is one or many hash set items, which is a struct that has one single field that would be a value or a hash set. So close to zero memory overhead, and it cut another like 10 or 20% of memory footprint. So it's a very interesting set of optimization that you can do if you look at another optimization that I was doing before, and I've created an open source project called Object Layout Inspector, and I've seen that like folks, Allende, author of RavenDB, was using this, and a bunch of other folks that essentially can print the layout of your instance in memory. And the trick is that in some cases, based on, for structs, I believe specifically, the field order might change the overall size of your instance. So, and just by looking at like something like byte short int long will take way more space than long int short byte because of the padding and whatnot. So I've done a few of these optimizations to cut the memory footprint even more. So
that's really challengeable and really interesting.
Yeah. So I've done quite a few really interesting things that you can, and a few folks were like super impressed that you can make a several, by changing just a few lines, you could have, for non-optimized code base, for that's a caveat, you can get like a drastic perf impact on the overall end-to-end application performance. For a well-optimized code base, like you cannot go to .NET Core runtime and just find such hotspots right now. Probably it's a well-optimized code base. Not probably. It is a well-optimized code base, well-optimized runtime that you won't find a such low-hanging fruits. But what I found is that even for a well-designed application, you probably, by looking into the data and by using special tools, you can find very interesting insights on how the system works and where the system spends the time. And you can cut, like, I don't know, like maybe improve 2, 3x, 5x perf overall just by cutting the some silly things that no one was thinking about, just because thinking about the performance requires you to essentially be extremely data driven.
Really cool. That's really cool. Thank you very much, Sergey, for sharing it. Yeah, changing the field order, especially really interesting for me. When you change the order of bytes in long, it changes it affects overall memory. So that's really cool. My question is how you are starting all this stuff. For example, you have a task to optimize something, to optimize some sort of application, and how you identify where to start. Okay. This is really important. The first start is really important, and this is really interesting for me. How you identify the first thread to start on.
So in this case, I usually challenge people when they start. So for instance, recently I had a discussion with one of our leads who was saying like, okay, let's move from system.text.json to from Newtonsoft.json to system.text.json. And I'm like, okay, that's good. That's a like probably will get some benefits, but what's the problem? So show me the data that proves that this specific optimization is going to help us. So, and for that, before tackling any perf problem, we need to establish the baseline, what we have right now, and we need to understand, do we actually have a perf problem overall? So for instance, in the case that I've mentioned, that was obviously like, okay, we have a reliability problem, and that's easy. In some other cases, it's not that easy to even establish what's the goal is. In some cases, it might be we want to just reduce the cloud bill, or we could reduce the P99 of our like responses. So there are like a bunch of research, and one notable one is from I believe from Amazon, that says that adding 100 millisecond to the web response reduces the like increases the essential like uh, increases the attrition rate, so people would leave the website by like single digit of percentages. So it means that the slower the website, the fewer customers you'll have at the end. So in this case, it's gonna be a business priority that we need to get like P99, which is like 99% of the time the perf should be X. And that could be a business metric. In some cases, it's just a reliability metric because we're getting the timeouts, and it could have a ripple effect. So the first step is to figure out, do we have a problem, and to try to establish what we're aiming for. And the next thing is to gather data. So I cannot emphasize enough how important that thing is, because you don't have, so the intuition in terms of perf is won't help you, because you're looking at this code, and this is a quadratic complexity algorithm. Is it a problem? I don't know, because if you have 5 items and you call this every hour, it's not a problem at all. But if it's on a hot path called with like hundreds of thousands of items, and probably every minute or every second, oh, that's a huge problem. So, and what's the current state is, what's the current duration be, like whatever the distribution of like latency and throughput. That's what I'm starting with. And normally I encourage teams to get the baseline in terms of like business metric. So that's the end result, right? Business related metric is the only goal that we really care about, right? Because if we cut memory footprint by, I don't know, a half, but it won't affect the end-to-end request duration, all of that is kind of pointless. So that's why I want to see the business related metric. And then I want to see a bunch of technical metrics, like the heap sizes, the time in GC, which is like extremely valuable metric to see, because it tells you how efficient your system is and how wasteful it is. The number of threads, the like how thread pool works, like you can get the data from like the queue duration and whatnot. So gathering like business metric first, and some auxiliary internal metrics second will help you figure out regressions and can guide you where the problem is. So after establishing this, like you have, let's say we have this startup duration that in our case it was like 2 hours, and we know that this was causing availability problems. Okay, so what's the reasonable target is like, okay, dropping below 1 hour, probably not probably, we know how the system works, how the deployment works. That's gonna increase the availability of the service by a decent percentage. Cool. So we have the baseline, we have the target. And then the next step is to figure out where the problem is. Okay, so in this case, we need tooling. So just by looking to the code, again, it's not gonna make it. We need profilers. And
exactly. My next question was about the monitoring the performance.
But we will go into the details, because like this is like just the tooling. I will walk through the overall overview of what we have, and then we can discuss in more details. So you have profiler to find the bottleneck. Then you need to establish a theory, what's wrong with the system, and the profilers, it's the best thing that can give you. So metrics like top level and drill down metrics can help you there, because the drill down metrics could immediately tell you that, you have an overall request duration and P99 is 10 seconds and P99 of one of the dependencies is 9 seconds. Okay, it's probably a good bet that and that dependency is Redis, for instance. Okay, so it probably means that we either have a bottleneck talking to that component, or we're abusing or not using that component correctly, because you can the fact that the downstream component it takes 9 seconds out of 10, it's not necessarily a perf problem for that component. It might be an integration problem as well. So the next step is the baseline, the theory based on tooling and metrics, and then we have a fix that we can do by changing the code, and we need to validate this fix as easily as possible. That's why I usually asking if we can get a kind of local integration style perf suite that we can mimic in decent degree of confidence a real scenario. So because from that you can change the code, rerun that thing locally, and see that before it was 10 seconds, now it's 6. Cool. You proved that your assumption about this perf problem is valid and the fix works. It's not always possible, obviously, and in this case, the second next step would be in some cases, I'm just using a test that I run multiple times. I'll still try to mimic this. So the closer to the real system your stuff is, the better. If you can deploy this to test environment really quickly and get the results, that's where I'll go. Then local scenario is the next thing. If you don't have any of that, you still can use benchmarking, like benchmark.net is a well-known tool. Thanks, Andrea Kinshin, for creating that. And you can validate, you can do the A/B testing. But in my view, this is you have this pyramid where the end-to-end thing is kind of acceptance testing, which is what we care the most. Then you have a test suite or a perf suite, which kind of a local integration testing, which is huge, which is real, which is really close as possible to the real world. And then the benchmark is a unit test. And we know that, or at least the industry experienced enough cases when all the unit tests are fine, but the end result is horrible and it's not working. So the benchmark.net is the final thing to compare, to A/B test a very small level of assumptions. And then with the smallest number of changes as possible, you need to get deploy to dev, deploy to test, deploy to prod, see the results. And in this case, I would be really cautious about the amount of changes. So in that service that I've started talking to, one of the challenges was that a person who was doing the optimization, they've changed a bunch of things at the same time, and some of them were helpful, but some of them were harmful, and the net result was positive. But without the portion of these harmful changes, it would have been even better. So in the perf world, one step at a time is extremely important, because just changing 2, what's the impact? Do you really know that actually this piece worked or that piece worked? Because I've seen many cases when in perf in particular, you can build this cargo cult when don't use this because it's a problem. Is it actually? Oh yeah, we've changed this and that, and it had massive perf impact. Yeah, but you've changed 2 things back then, and that's why you cannot claim that specific thing changed. It's this or that, and now you don't know actually. So for this thing, it needs to be a small step. And when I was doing those perf changes, it was probably 50 different small changes, one step at a time. Otherwise, it won't be possible to reason about the nature of your change, the impact, and whatnot.
That's really cool. So you mean that the one step forward is better than doing everything together, yeah, when optimizing?
Yes. Yes. Yeah. And again, you can deploy 2 things, but in this case, you need to validate one thing separately with a decent confidence on the end-to-end impact.
Cool. Cool. What type of tools are you using when monitoring all these performance stuff? For example, you should have some sort of environment with different tools for getting metrics, for estimating all this stuff. So what type of tools, monitoring tools, are you using?
So in this case, it's again, this is a hierarchy. So normally in like, so this is like metrics and benchmarks and profilers. And metrics are available in any environment. So this is intended to be available in any production environment, right? And that's what you, as I said, you're building the baselines. It's based on metrics. Then you might or might not have built-in tools for like built-in profilers in your environment. So for instance, in Azure, there is like Azure Profiler, which is like this sampling-based profiler that can be configured where to run, but this is like production-ready type of profilers that you can get the alerts and whatnot. And this is again the second best thing, or like it's very important because it's on real data. Then you have special profiling tools, like my favorite is .trace, and I can explain why. That you can run on a like in some cases you can run this on Unreal system, like in test environment. It's usually okay. It's again the overhead is actually quite low. It's like 10-ish%. But still, like so for instance, in Azure, you just cannot run any tools in production system. It needs to be signed and whatnot, so you cannot, you don't have this option. And in this case, you can run the same set of tools on that integration suite that you have, or in unit tests. So because like again, unit test is kind of like it's in a test runner. So .trace integrates with ReSharper into test runner, and if you have an end-to-end test in the test, you can just run that and see the same overview. And in this case, the main benefit of .trace that I love, and I'm kind of like, why no one copies that because it's so obviously a good thing, is you're getting this. Have you tried using .trace ever?
Yeah, exactly.
Okay.
I've used it.
So this, there are like different modes, right? And one of the modes is timeline view. So, and the timeline view shows you that like, okay, we've been running for a minute. Usually that's what I'm usually aiming for, from 30 seconds to a minute. Otherwise, the amount of data won't allow you just to open that. So in that minute, and you can see this minute, you can see the number of threads, a number of allocations, what the hotspots are and whatnot. And the reason for why I love this is because it gives you an intuition of like, okay, so few threads were running here, then only one thread was running here, and then another 15 threads were running there. Oh, okay, so why in this section only a single thread was executing work? Oh, okay, we can increase the concurrency there and split this work and get things done. And it shows memory, allocated memory. And we probably can get into more details why I love using memory allocations as the proxy for performance during the performance analysis, and this is like super cool. So without the tooling, it's almost impossible to figure this out. So maybe a year or a year and a half ago, I was like bored in the evening, like, oh, I want to watch something perf specific, and I looked at a Plural site, which is a decently it's a very, very famous platform, and I picked a course on performance. And the first thing that the author said was like, oh, I don't like profilers. And I was like, wait, what? For me, the profiler is such a foundational tool for perf analysis.
Exactly.
And like, again, sidestepping a short story that happened like literally a few days ago. One of my colleagues ping me, like edit me to the PR, and like he says like, okay, so here's the snapshot from Azure Profiler that shows that this specific code is on a hot path. Hot path means that it's like executed a lot. This path hit many times. And he like, okay, so this is a link any method that does a sequential scan of another collection. He changed this to hash set. in the comment, like I briefly looked like, oh, okay, you just can change like literally one line. He re-implemented the method like with before and after, and it's like just with one line it should be enough with like a few keystrokes. And then he said like, yeah, I did this, but the results are almost the same. Like the before and after is like something like 60 seconds versus 57 seconds, like 5% perf improvement. That's nothing. So in this case, you normally you would not sacrifice the code readability for 5% in normal circumstances. In some cases, it's useful, but normally it's not. Like, okay, so I again ran the .trace for this unit test, and like, oh boy, 95% time is spent in logging. Like, oh, so we optimized one thing, but it actually was like the logger was creating a stack trace, and the stack trace is extremely heavy operation to get the method name. So it's a suboptimal, like very not optimal implementation. I cut this piece, and the perf dropped from like 60 seconds on average to like 15 seconds for both versions, roughly the same. Okay, again, it's very high. I cut the logging completely, and then we got like the old version was 4 seconds, the new version was 2.5 seconds. So when I was on the call with this person explaining this, he was like, oh yeah, I wouldn't like it's not possible without the tools to see this. So that's the benefit of tooling too. It will point to the right thing in many cases very quickly if you have long hanging fruits. So that's why profiling is your friend. It's like you need to know them, otherwise you'll be wasting so much time. You cannot find the hot spots by thinking, by looking. It's very hard.
Great. How about building your custom, some sort of, I don't know, the profiler-based application? Was there any need in your development process, especially in Microsoft, to build a special tool that you don't have in your environment? There is no such type of tool, and you need to build something and to measure something. How about this?
So one thing that I have, which is not a profiler. So in .NET, you can inspect the code, or like there are like some ecosystem for that. One of them is called CLRMD, and you can open memory dump. You can get to attach to a running process. And I have a tool that does essentially what parallel stacks, parallel threads does in Visual Studio by grouping them. And in some cases, I was using this as a very, very naive profiling tool. So again, I can run that tool in our prod environment, but not like .trace. And in many cases, when we had like, when the application stalls, like, oh, you need to figure out what's going on right now. And I've been like, oh, and just collecting a memory dump for like 400 gig project, or like even like 50 gigs, it's quite hard. So this tool allows me to eyeball what's going on right now. And that was helpful for me to find like, oh, like we for instance, we had like SQLite cache, and it was like 400 threads were blocked on a lock. Like, oh, obviously we have a problem there. And I've been using this with a friend of mine investigating other perf problems. So that's type of tool I've built, but nothing like profiler-like, to be honest. But this might be a good starting point to do something like that. So this thing is quite complex to build by your own. So I would encourage people to figure out the existing tools. Yeah, so we have PerfView, which is a very, very advanced tool, but the user experience is quite hard, but you can do a lot. So in this case, I would say that if you know something about the system, that's a way. By the way, another way is .trace actually provides a NuGet package that you can create a custom listener. But again, in this case, it's not more than a runner. So in this case, your application can detect a symptom that something is off, and you can run a .trace session, and then it will save the .trace session to a shared location that you can get. So that might be a good option, even though like for most production Microsoft products, it's not gonna work just because that NuGet package will download essentially .trace.exe, and since it's not signed by Microsoft, you won't be able to run this in production environment at Microsoft. But for your projects, for your cases, it might be a good way to look into that. It's very easy to integrate. So
That's great to know. From the when I think about performance, the first thing came to my mind. One of the first things is understanding maybe intermediate language, all of the behind of the scenes. So, what do you think about it? Have you ever had the chance to use the intermediate language to replace with some part of code with the original intermediate language and boost your application, or it is just nonsense? There is no need to understand to learn intermediate language. What do you think about it?
So I would say that for a to be a good in performance, you need to understand several layers deeper in your application stack. That's for sure. It's a very, very good thing. So overall, to use low level like IL rewriting for something, I would say that in most cases you don't need to go there. So like in what I would say that in perf you have multiple ways how you can deal with it. So first, when you find a bottleneck, you need to, like as we discussed, the first step, identify. Second one is fix it, and by fixing it can be very interesting. So here's an example. Literally, I've done this. I did this fix 2 weeks ago, and it was a nice like journey, and I can explain this. So I looked at this again, Azure Profiler, noticed that one of our core services spends a lot of time in constructing essentially concurrent dictionaries. It's a concurrent hash set, which is an open source project, which is essentially a fork of concurrent dictionary. I was like, okay, so creating concurrent dictionary, concurrent hash set, okay, maybe their implementation is not great. So let me try to benchmark and compare that implementation with essentially a custom one based on concurrent dictionary, on real concurrent dictionary. I measured roughly the same. Like, okay, that's not it. Okay, so how to speed up the merging process? Okay, maybe I can use a different constructor that won't take a global lock. No, that didn't work. Then like, okay, but why do we merge them? And then I look like, oh, we merge that for every request, but that thing stays in memory, and it doesn't make any sense to merge that. And we actually merging like 2 of them all the time. Like, oh, but it's instead of making that merging process very optimized and optimal, or maybe by switching from concurrent collection to a normal hash set, oh, I've created an adapter that can take 2 concurrent hash sets and implement essentially 2 methods for each, like get enumerator, and contains that will look at the left and the right. And that's it. So, oh, I can avoid that work completely by looking into this problem differently. So this whole story is when you need to go that deeply, the question you should be asking yourself is why? And in some cases, you can do some relatively mid-level techniques, and I think I've seen you posted a video about expression trees recently. So another example was that I've noticed this again, something was off in terms of perf, and it was a very heavy reflection-based logic to merge 2 collections. Like, okay, so let me think how to do that. Okay, I can create an expression trees and can cache them, get the delegates, and avoid all the allocations. Got the perf boost for like, I think it was like 30x perf improvement and 50x memory improvement. Cool. So but that was like a very naive version implementation that was used a lot, and changing it a little bit, even actually just caching reflection information was boosting the perf by 10x, just by one liner. And maybe it would have been enough. I've decided to make a further step. So I would say that understanding the IL is very important for like post-mortem, for figuring out the like what's going on in some corner cases and whatnot. It's a nice tool, but I would say that if you need to rewrite the code at runtime to get the perf boost, probably something is off. I never I never had any needs to do that, and I've been dealing with relatively high performance system level, like kind of like low level ish systems, and it was not needed. Very nice, very useful. Please watch your videos. It's very nice. It's an important things, but I don't think that you need to go there.
Got it. But so yeah, how about the business perspective? I asked this question to Bertrand Meyer also about the business. So you're optimizing something, okay? And maybe the written code is not a completely describes the business. Do you really need to understand business? Okay, for example, I wrote some code and you need to optimize it. Maybe it may somehow that 60-70% reflect the business, but do you think that you need to completely understand the business, the requirements, and then start this performance checking stuff?
It's a very nice question, and I would say that what I've been doing like recently, you definitely can. So, for instance, the hash set, you can like, oh, that's just useless. You can figure out that from technical point of view, you can achieve exactly the same results by just doing this in a more optimal way. But I would say that the best optimizations possible are business related. For instance, you have a backend and you have a code that pulls some data every 100 milliseconds. And you have 1,000 servers. Obviously, that's going to be a problem. I cannot say without business knowledge if I can change that. And like, of course, you can say that like, oh, but you can create a different architecture. Obviously, you can, but in like, let's be realistic. It might take quite a bit of time and risks and whatnot. And the second thing that you can do is to ask a business expert if that does make sense or not. And the answer in some cases might be, oh, wow, whoa, no, we don't need this. And I've literally had this type of optimizations, which is like the best type of optimization that like you can optimize 2, 3, 5x, but you cannot eliminate the work completely. You don't know, like you need to know the domain to answer that if this is a completely useless work that we're doing here. One example was that I was looking into some piece, like we have some pipeline, some logic, whatever. And at the end, we were sorting the data. And we were using a culture-specific comparer, like invariant culture, which is like, even though it's like culture agnostic, but since it's invariant culture, it actually tries to search the character, like Unicode boundaries and whatnot. It's way less optimal compared to ordinal, for instance, or ordinal ignore case. And I was like, oh, okay, I can change this to ordinal. And oh, yeah, I got like, I don't know, 30% boost. And then I was talking to the guys and like, oh, no, but we don't need to sort at all. Cool. Oh, wow, we can remove this. So like, you can optimize the sorting, but maybe you don't need it, right? So like, you cannot optimize as much to completely eliminate the time for that. And for that, you need to know. So the quick answer, the short answer to that is both. In many cases, you can, but in some cases, you can get the most out of the system by having by knowing the system. I will send you a link to a video. I can't remember. The guy is brilliant. I think it's Martin Thompson, or I guess. And he had a bunch of videos on conference talks about perf and how they built a trading app in Java, and it was like the best in class in terms of perf. And the idea was that very expressive language, high-level languages, gives the team the opportunity to deliver faster and figure out the problem domain deeper, to embed, to apply business-level optimizations that would beat any C-level number crunching thing, because you're just doing the things differently. And that's a type of thing that for top of the line, that's unavoidable. You need to know the domain, and then you will apply some specific optimizations. You will kind of like merge the abstractions because you have to, etc. So many things will come only from the business expertise. Yes, that's very important.
Yeah, that's cool to hear. So, in your practice, have you ever meet some task that changing the .NET version was enough for the optimization? For example, you have .NET 6 and moving to .NET 7 did a good job, and that's all the optimization perspective.
Okay. So obviously, everyone who's interested in .NET performance are aware of this ginormous blog post that Stephen Tobe writes every year, and those optimizations are real. So after I've done this memory optimizations for that project, the guts of that projects were used in some validation pipeline, and we got like some decent perf improvements there, and the build time for that build queue dropped like from like 2 hours to 45 minutes and whatnot. But then another person jumped in and migrate that from full framework to .NET Core, and he migrated to .NET 6, and that caught another 2x or 4x, improve the perf drastically again, just by moving from full framework to .NET Core. And obviously, like with .NET Core, each version has a bunch of optimizations, and you can, depending on your load, it might be extremely useful, it might be just useful, it might be barely useful if most of the stuff is spent in something else. It might be like IO related. But yeah, so moving to .NET Core is in a very, very useful investment that you should think of in terms of like tooling, in terms of obviously in terms of perf, in terms of security, in terms of observability, because there are so many more things there. So that's definitely a nice thing to do if you're not there, to think how to invest there.
Related question is, what can you say about .NET Core and the .NET Framework, classical .NET Framework, about the optimizations in both?
Yeah, so that's essentially this example that they gave was that. So it's a massive changes. Specifically from full framework to .NET Core, you probably will get the biggest impact. And there are like multiple reasons for that. One is, so for instance, a bunch of link is being optimized to have vectorized support. So, and even though like technically from our CS school books or textbooks, the algorithmic complexity stays the same, but the constant will change so drastically that just using a sequential scan using iterator versus using a span-based search will give you probably an order of magnitude perf difference just for that. And essentially, I don't know if you want to talk about spans or not, but this is essentially a foundation for high performance .NET right now. It's everywhere, and it's an extremely nice abstraction. So it's not always the case when the building block is very, very well designed and so useful and so easy to, so it still abstracts things correctly. So for instance, IEnumerable can you tell me what's the semantics of IEnumerable? Right, so like this is something that you can get the next item from. Is it in memory? Oh, you don't know, right? Because it can be generated on the fly. So if your method takes IEnumerable of t and it iterates over this twice, is it a problem or not? Oh, but unfortunately you don't know. Because enumeration might have side effects. It might be backed by a file with a link or whatever. It might go to the database, and you will go to the database twice, right? But span is like, it's a zero cost abstraction. If you have span of byte, okay, so there are like one very interesting corner case when the abstraction might leak, because you can create a span from unmanaged and managed memory. And so, for instance, if you create a span from a pointer from memory mapped file, then it's not actually random access. Accessing that thing will actually trigger a whole chain reaction. You will see this. But besides that, there is like zero overhead, super optimized. You will get the same performance regardless of what the data there is. So very nice abstraction. And yeah, so .NET Core, and there are like a bunch of other things that you will get only on .NET Core. You can use, by the way, like you can use span in full framework, which is called like so-called like fat span. Because to get the slim span, which is like a few like 4 bytes or like pointer size shorter, you need the runtime support. But you won't get as many perf optimizations because they were baked into the JIT compiler. But you still can get a lot of benefits. So like a ton of new JIT optimizations that only are available in .NET Core, profile guided optimization that is there. .NET Native is like, there are like some versions for full framework, but they're like way less popular and whatnot. So a ton of things in terms of perf that new GC modes are only available there. So for instance, one case, if you're one of the critique for server GC, so you have like 2 GC modes, the 2 main GC modes. It's the workstation and the server GC. The workstation is optimized for latency, and workstation is optimized for latency, and the server GC is optimized for throughput. But the server GC is way more greedy. So if you run a relatively memory intensive application on a small box, that's probably might be a problem. So recently they've added an adaptive mode that will actually be way less eager in terms of memory allocations and creating segments and regions and whatnot. Super cool stuff that will be only available for .NET Core. Yeah, and obviously cross-plat if it's something that you need. But even without that, even .NET Core Windows will give you a huge number of productivity things that you can rely on.
That's great. So yeah, I really want to ask that for me this is really interesting. The effect of our architecture to the for example, I have some sort of architecture, okay, some sort of application, and I designed it using all my skills, let's say, all the design patterns, all the principles. I tried to do everything, my best, the loosely coupling, all this stuff, and here we are. You need to do some performance optimization. So how all this stuff affects to the performance. For example, let's say I'm using for example, in your book, you mentioned that we have the dispose pattern, yeah, Microsoft's dispose pattern, and people sometimes just use, because Microsoft recommends using dispose pattern, okay, let's use dispose pattern, but we don't have unmanaged resource. We have only managed resource. When you wrap all this managed stuff to a class that is going to be managed, when you have the disposable stuff, this is managed. When I have, for example, working with pointers, all this stuff, I have unmanaged, but I'm just using disposable pattern because this is cool in my application. I have
Okay.
proxy pattern, I have factory pattern. I'm trying to do my best. So how this affects the performance?
So in this case, as always, the most useless answer is, and most honest is, it depends. Because again, the perf problems are probably not like, they're most likely not well distributed, right? And you have some bottlenecks. So and in this case, like when I think about like performance versus a good design, and there are some cases when they're in odds to each other. So in some cases, performant code needs to be written in such a way that breaks the abstractions, for instance. So for instance, instead of like, because like in some cases, to isolate the pieces from each other, you need to pass the data, and in some cases you would have to copy the data. So that's obviously a perf bottleneck there. In some cases, you have to allow other components to poke into your data to break the encapsulation for that. So there are like decent chances that for a very, very high critical, high performant code, you would have to design the system differently. That's why you probably cannot go with let's design with all the possible abstractions a web framework and then optimize this. So if you look at Kestrel, the tendency for those types of things is to merge the layers, not to increase the layers of abstractions, just because it is costly. So that's why, so for instance, if you look at spans and like channels and pipelines, new high performance patterns in .NET, you will see that they're trying to hide things, but they're like, you need to know about memory management. You need to know who owns the buffers, who owns the data, what can you do with that, and probably as a like you have a pipeline, and in the middle of that pipeline you're getting a span, so you, or like a byte array in some cases, you cannot just store it somewhere because probably you will cause memory leak. So for this for platform, you have to design the platform differently for it to be very efficient, because you don't know the context in which this platform is going to be used. And any overhead, any abstraction can actually harm performance. On the other hand, for applications, that's probably, I would start with so right now I'm not like a big fan into like I'm using, again, it's probably this level of expertise that you don't think in terms of patterns, you now thinking about something even more abstract, or like, does it make sense? So I will I think I don't I haven't used these words even when discussing things with more junior people, for instance. I will try to use something like, does it make sense to split this together? I won't say like, oh, this violates single responsibility principle that Bertrand Meyer and whoever wrote about, and like, oh, no, it's just like, oh, I feel that this is just too complex. What if we'll do it in a different way? And in application development, it's just going with like, and it not nothing wrong with using, like, we still use a lot of factories and whatnot, so we have a lot of patterns that are naturally used in our applications, but so just try to think about, yeah, like what I'm usually thinking about, if you can be in your application development kind of narrow-sighted, and if you can reduce the size of your focus window as much as possible, that means that you have a good design. It's not a scientifically based, it's like not something that like you can quantify, but I would focus on does it make sense in terms of coupling, does it make sense for this thing to do that much stuff? I will start from there, and then we'll look under the profiler. So for applications, don't bother that much about profile. Don't mess up with your design upfront. So I've seen cases and I had talks with people who've added like object pooling in your application, like almost for every type. So like, I don't think that having an object pool for an object with like 24 bytes will ever make sense. It just probably not. And again, especially when I've asked, I never got like before and after numbers, so I didn't get like, oh, this is for sure useful. But yeah, so don't over optimize for no good reason. Measure and just go with a reasonable design that will improve your dev's productivity first, to again focus on delivering the value first and then get back and optimize. Unless you're a platform. For the platform, you would have to design it differently with different design patterns, actually. So there are like literally different design patterns, right? So span is a pattern that is used in many languages. The channel is a pattern that is used again in many languages for high performance things. So it's gonna be a different set of patterns probably.
That's great answer. Thank you very much. So we have the special section in .NET called memory management, okay, the garbage collection, all this stuff. And as you know, in many books, unfortunately, they just somehow bypass this topic. They are trying to explain all this stuff in theoretically, but seems that many of them don't have enough practice to explain the real value of this, understanding the memory stuff, the garbage collection, when to use the suppress, finalize, all this type of things. So what's your advice as a performance expert from the garbage collector perspective? How much should we understand to say that, okay, I can start to do some sort of performance optimization?
Okay, so like suppress, finalize, obviously never, because you should never be trying to mix manage and manage resources. It's one of my pet peeves with this classical dispose pattern. It's so bad, no one, okay, whatever. Okay, distracted. So back to memory. So the GC is very efficient. That's one thing that you should know. And in most cases, you indeed should not pay too much attention. But again, if you faced with perf challenges, there are like some. So in terms of understanding how GC works, I would say that it's important not for perf per se, even though it might be useful to understand that if you put this in a static thing, it's gonna sit there forever, right? Or to avoid, like, I've seen cases when people were setting locals to null, right? Like, okay, so, okay. If it's an async world and if it's not being optimized yet, it might work, but do you really understand what are you doing there? And in many cases, if there is no this lengthy comment explaining this thing, probably the original author either super smart or actually don't understand this thing. And at least in my perspective, people who use some very advanced technique, they understand that this is an advanced technique that almost no one knows about, and would tend to explain this in lengthy details. So in terms of correctness, in terms of like just generally, it's a very useful knowledge. And probably understanding the impact of Gen 0, like that we have generational GC, right? And then that the one thing that, for instance, for a perf enthusiast is very important is to understand that the GC efficiency is inversely proportional to the number of objects, to inversely proportional to the number of survivors. So it means that if you have you run this code and most of the objects are gone, that's going to be a very efficient way to collect them. But if all of them stays in memory and your memory footprint is 40 gigs, the GC would have to rescan most of them over and over and over again, and the overall efficiency will go down. And in this case, it might or might not be a problem. That's again getting back to metrics. You have time in GC. If the time in GC is, I would say, below 10% is quite good. Like, so for high perf code, I would aim a bit lower than that, probably for 5%. Below 10% probably don't bother. 30 is like, okay, so 1/3 of your application throughput is gone to the GC. Maybe that's not perfect. It might be okay, but already some hints of that you're wasting time. 50%, probably you should start looking. 80, obviously you have a problem. And I've seen cases when like just switching from workstation GC to server GC improved the throughput by 3x, right? Just by looking at this metric. Just because, again, that was a number crunching job and the server GC is way more efficient. So understanding that is important. But the second thing that I use memory analysis for is kind of a proxy for waste. And it's interesting, if you have watched this, it's called Highly Technical Talk by Scott Hanselman and Stephen Tobe on the Last Build conference. Steve gave the same advice essentially that I was following like for many years already, and obviously he was following the same advice for even longer. That he said that like, oh, essentially the same thing, that the GC time and just allocations that are transient can be viewed as a proxy for waste. So when you're looking at just into you open .trace and like, okay, so you've spent this time here, this amount of time. Is it okay? You don't really know. But if you see that this thing allocated and then essentially discarded an array of your business objects or an array of bytes, that like, oh, someone asked GC to create this set of objects, populated this with data, and threw them away. That's work, right? So can you use that data directly and avoid copying this? That's a source of just useless thing. Or another thing is that when you're looking at the number of iterators allocated from link, so normally you have any link extension method. Again, it depends on the runtime because a ton of optimization was put there, but let's say you're on .NET 6 or on full framework, and you can see that you have hundreds of megabytes of iterator allocations there. Oh, whoa. So we iterated that thing millions and millions of times to see this. Does it make sense? Oh, but that collection, actually, we have a nested loop. We have a quadratic complexity that was hidden. It's not obvious, right? So all our levels of abstractions that we were talking, that is very useful. It might be that your code iterates over something, and that code is called in the loop. You have an n square, and maybe it's okay. But now you can see that you have this n square, and you can find very interesting insights by looking into what type of allocations do you have and what type of work that is done by the system, and does it make sense or not. So that's a huge source. I almost always, the first thing that I look is how much allocations do this process have. The max for now is 100 gigs per minute that I've seen in the benchmarks, and like obviously it's a lot of work, and that's and you can see that like in workstation GC that will die. So workstation GC won't be able to handle even close to that, and obviously it's a very heavy loads and whatnot. But you can find like, oh, this is again, can we cache something? Because again, the allocations indicated that We created something in the process, and that's super, super useful for me. I always go with the memory allocations in terms of perf analysis. And it sounds unintuitive, and that's the reason why I love that trace and its ability to show that thing immediately. Because you can narrow the scope, you can see like, oh, all these iterators or like closure allocations. It's a famous source of perf bottlenecks, especially if you're on the system level, like platform or library. You cannot afford closure allocations, iterator allocations, because you don't know in which context your stuff is going to be used. So in that case, it should be close to zero tolerance to closures and whatnot, because that optimization that I was telling this story about the logging, the new version actually caught in that test case 7 gigabytes of allocations. That's a huge amount of allocations that you can cut. And on the long term, it affected the perf. So in this case, it's like one of the patterns that I've seen. It's essentially two like distinct patterns that you can think of in terms of perf. One is you can easily see the bottlenecks. Another one is that it's called like death by 1,000 cuts, when the perf, like the waste is spread relatively equally through many places. And in this case, fixing one is not gonna make a huge difference. But then by cutting the allocations from multiple sources, you ended up seeing a 2x perf boost for your application because of eliminating this waste. So be mindful about them. Don't like be crazy, because again, you need tooling to understand when it matters or not.
That's great. In terms of optimization, Sergey, what do you think? Was it always possible to simulate the production-based issues in local environment and test environment, or what did you do when it is okay? Do you have some snapshots from the production that we have this issue, but it is not possible to simulate in test environment, in local environment? How you are dealing with this?
So in this case, there are like multiple things, right? So you normally build an intuition about can you trust your data. And in this case, so for instance, this optimization, the memory optimization that I was doing is like I don't have a machine with 500 gigabytes of memory. So, but in that case, I just was able to get a portion of the data and extrapolate from there. And actually, it was like even so, my optimizations locally were very nice, but in prod they were even better. So so it was like the other way around, right? So like I cut like let's say 20% in the my test, but I cut like 50% in prod. In some cases, it might go the other way around. And in this case, you will just you need to work on enhancing your abilities to mimic this locally one way or another. So unfortunately, there is like no other way, because like I mean, it's like literally, can you go to prod with your tooling? No. Cool. So the best thing you can do is you can run some tests and see something. So in this case, what I would do is you still can see that in prod, this top level thing takes a lot of time. And the next thing is you need to make sure that you can run the same thing locally, and it's normally doable. You can use fake data. It's very rarely that you have a specific payload that does that. In some cases, it might be, right? And in this case, unfortunately, you would have to figure out what type of payload causes this. So for instance, you could have like not this outliers, perf outliers, that 1% of requests is taking like ridiculous amount of time. In some cases, in many cases, that could be like literally the outliers, because you had something going on in the box, you had GC pauses, whatever. So the same request might take 5x, 10x more time. But in some cases, it's like specific payload that causes that. And in this case, you have an assumption that it's a generic problem. You made a fix, deploy to prod, this stuff stays the same. Okay, your experiment failed. You should understand that not all the perf optimizations will give you good benefits in reality. You need to step back to figure out what potentially was wrong in your assumption about the system. So your understanding of the system lacking, right? So you misjudged something. So let's go back, try to figure out, try to mimic, try to figure out what can be done, simulate this thing, break down, add more metrics to the system, add more telemetry to the system to figure out those outliers. For instance, one way to deal with this is trace. So like you have a kind of a pyramid of like observability pyramid. And on top of that is metrics. Metrics are the foundation for alerting usually, and they're the lightest in terms of you can generate like hundreds of millions or billions of them easily in the production environment. The next thing is traces. When you have a causation of a thing, and in some advanced modern advanced techniques where they can do some type of sampling, and they can actually, you can go from metric from this P99 outlier, and you can see the trace, and you can see the breakdown. So they're like right now there is a tendency to mix profiling and observability, but it's not there yet. For instance, in this case, you can add a tracing for long operations. So you have a metric for all of them, but if the operation takes more than n seconds, milliseconds, you will trace and embed in the logs more data that will help you to figure out the problem. So there is no one thing fits all type of solution. You would have to think, you would have to check your assumptions, you would have to build a mental model of why your assumptions are wrong, your understanding of the system, etc. So that's what I would do in this case. I would try really hard to mimic this locally. If not, I will try to get as much data as possible to figure out where the bottleneck is in the real system. But I cannot emphasize enough, you need to get the data. You cannot make any calls without the data. You'll be wrong, probably. You can mess up with the system, you will break the system, and for no good reason. So changing the system, and especially making perf optimizations for no good reason, is no fun. It's a lot of work. You can break things, you can regress the perf. No good. You need to get the data.
Exactly. How about saying it is enough? You have a task and you're doing all this stuff and you're getting, let's say, 25-30% of optimization, and you're saying that, okay, that's enough, the task is done. How you are defining this
success criteria? So in some cases, so there are like multiple ways. So the performance optimizations are addictive. So everyone who was looking into perf, they realized that it's data driven, and you can see that like, oh, I can remove this yet another memory allocation from here or from there, and I can see the results. They're tangible. So like, oh, I caught this 10 megabytes of stuff, but is it worth it? Is there an end-to-end impact of that? So in this case, I'm trying to, in one case, I just told my manager saying like, okay, let's time box that. Please pull me out from this task in 2 weeks. I'll try my best with this time box period, and we'll stop. So that's the only, it was half jokingly in one of my one-on-ones, and he never even asked me to stop. I stopped him before that. But so that's the idea why you need to start with the goal, right? Because if you have a goal, so By the way, you don't always have this goal. So for applications, you normally have a goal. For other stuff, if you're a platform, that's where you need to kind of probably define the metrics in a slightly different way, because you probably need to figure out the cost and benefits of, like, oh, do you have any assumptions about what's wrong with the system? Oh, you have a theory, you have a few fixes, you can try, validate, and stop. And just in this case, it will be like, oh, you have a bug report that a concurrent bag is not optimal in this scenario, and you will go from there. So for platforms, I would say that you again need to be data driven and need to be driven by some real requirements from your team, from yourself, when you identify some bottleneck that matters, or from the customers, etc. And for application, it's again, it's like you can define some KPIs that, like, oh, our perf is problematic. Yeah, and in this case, if you have a more clear goal in mind, it's easier to stop. That's what I would do. Yeah, and again, don't be discouraged by the fact that some perf optimizations might be harmful, and you can I've wasted a decent amount of time trying to make the solution better than measured, and oh, it was given a positive result in the benchmarks, for instance, but when I tried to deploy it, I had to revert because it was more harmful, because I make it wrong. So it's fine, but defining a clear goal is a good thing. And if you just doing this for fun, it's nothing wrong with that. So I'm a human being. It's nice to have fun. Just time box that, not to sacrifice too much of other stuff. But yeah, I don't see anything wrong with having fun and trying to balance this. When it's not 100% fun with zero business impact, that's not what I'm suggesting. But doing this in 10% of your time, just because you can learn the system better, you can get some interesting insights. Performance is fun. So
How about the user story formalization perspective? For example, are you getting the task that exactly defines you should get 25-30% of optimization, or just relatively do your best?
So I would push back relatively strongly if someone will put a work item to anyone on the team saying that we need to reduce something by 25%, because you probably should not think about perf that way. It's dangerous in the sense that there's a notion of diminishing returns, right? So what if you can cut 20% super easily in an hour, but it will take another 5 weeks to cut another 5%? Will you take it? I won't, probably, and probably I would stop with the first thing. So I can remember, like, normally the perf is neglected in most cases, and if you have a lot of perf enthusiasts in the team, probably it's a slightly different dynamics how people deal with perf. That's my take on that. Usually it's kind of spikes. There are like some, for instance, it might be a what we call, like, maybe everyone else calls this the same, repair item. So we have an incident that, like, we have a spike of timeouts that was causing that, and I would go with that, like reducing the timeout rate, right? Because just by cutting memory, what for? Do we have a problem? Or like, oh, we like in my case it was, okay, we need to cut the memory footprint because we cannot enable all the feature flags because we're running literally out of memory. Okay, so you have a reliability problem built into perf problem. So perf is a solution. You need to, I always will try to see what's the problem we are trying to solve, and do we have other options for doing that. Let's say that this 20%, maybe you can cut 10% easily and buy slightly beefier machines. Is it an option? I don't know, because in some cases it might be, in some cases it won't be an option. So, but don't be like super like fixated on the perf numbers. You need to see this in a context. Otherwise, it might be a problem. Yeah, but normally, like the stuff that I see, it's usually comes from some kind of incident, some kind of like investigation, some kind of a very specific problem that is high level problem that we're dealing with.
That's really great answer. How about asynchronous perspective, the multi-threading environment perspective? Let's say uh, the, the effect of concurrency to the performance. Okay, I mean all this the async await stuff. I don't know the threading stuff, etc. All this stuff. Let's do one by one. Let's start from the value task and the task. The Microsoft has task and the value task, and we usually, as you know, we are using for the service layers, all this other layer stuff. We are using the always task and but in some cases we need to use, for example, value task. Have you ever seen the performance issues using the vice versa stuff?
Okay, yeah. So just a quick recap. So by the way, we're I think like asynchronous and parallel. We should look at this from two separate different perspectives. And right now we're obviously talking about asynchronous thing. And so the task is kind of a promise that you have a potentially operation that is going on, not like normally it's not on your box, so you won't represent a CPU bound operation. It's kind of IO bound operation that you will start something, you will send the data to something else, and that something else does the job. It might be a hard drive, it might be an IO layer, it might be another process, it might be something on the other box, etc. So, and the idea is that once that operation is done, you'll get a callback from the runtime and you'll continue the execution. So we have a logical sequential set of steps that will happen one after another, but they will be running on potentially different threads. Again, let's remove synchronization context idea and whatnot. So, and when if the operation is actually is synchronous, there are like a bunch of optimization that you can do and reduce the overhead for that. But if the operation is actually asynchronous, you would have to create a state machine that will be boxed, and that might be visible. So in this case, if you care about that, you're not in application development land. This is a platform or a library. So in application, it's extremely rarely. I've seen cases in one of our layers that we've switched to value tasks, but this is a very high performant cache subsystem for the build systems, and that layer was dealing with like RocksDB layer and whatnot, so was called like hundreds of millions of times per hour and whatnot. So that's where like, and if you use a value task, so essentially there are some relatively obvious guidelines for value task versus the task. Value task is primarily was designed when, so value task is essentially a union between the result and the task of T. It might be either value already or a promise in the future. And that was designed for the case that in, let's say, 90% of cases, you can get the results already. And in the 10% of cases, the results won't be available. Something like read byte async from a stream. Stream has its own buffer. So in most cases, that you can get the data immediately, synchronously. But in some cases, when the buffer is empty, you would go to the file system to read this buffer, and you will get the data from the buffer. That was the main case, that you have 90% case synchronous. Then with value task source and whatnot, you can optimize even further and avoid any allocations even for value tasks that are not completed synchronously. So very advanced, not super, like there are some building blocks, but not super easy to get it right. With value tasks, the API is way more complicated. So for instance, how many people know that you cannot await single value task instance more than once? I don't know. probably not too many. There are some static analysis rules for that, but they might be off, they might be puzzling, and people will just suppress them. So dealing with value task is a design choice, and this is a compromise between actually making your API slightly more complex in favor of performance. So please measure first, you'll see the impact, add a comment how to use it, and go for it. I've seen cases when it was useful, but it's very, very low level and advanced in here.
How about the usage of async await keyword? The effect of using async await to the performance.
So again, it's a non-zero overhead, but we're naturally dealing with, you're probably going out of the box with this, right? So like you're dealing with async land. So you're in async land, meaning that the stuff that you're awaiting is probably not immediately available. So, okay, one example. You cannot probably switch from blindly from synchronous streaming API to asynchronous streaming API without measuring. So I don't remember where the bug report was when it was when that change reduced, like regressed the perf by an order of magnitude. Because like just a reminder, when you have a stream, you have read byte or read byte async. And if you're dealing with a network, probably it's gonna be okay either way. But if your underlying stream, or in this case it was maybe text reader or text writer, so a few levels of abstractions. But when you're dealing with memory stream, reading from memory stream is extremely fast. So having an overhead for async await each step, even though it was done synchronously, will give you this const. Remember, like algorithmically, this is the same, but we have a const which is different. And in this case, it would be very different, and it's gonna be quite a bit. Another example. So in that cache subsystem, what we've done is we had a lot of binary readers and binary writers. And again, fully synchronous. But the overhead for like essentially deserializing was quite high because of so many layers, virtual calls and whatnot. We've added a layer or abstraction to read and write from spans. 10x perf improvement, right? And async await is the same. So if don't go blindly with like, oh, you have an async API, like alt enter type of development, your IDE suggests to make a fix, let's make a fix, commit and move forward, right? So that's probably not a good idea. In most cases, you would not care. You will not notice the difference. In some cases, you might. But the overhead is, like, if it's used, like, you need to aim for relatively coarse-grained asynchrony, meaning that the task that you're dealing with should not be, like, in microseconds range. The overhead is not negligible. It should be a relatively long-lasting, like, so milliseconds range at least, or hundreds of milliseconds, or seconds, or hours, it's gonna be okay, but not in microsecond land. That's not the way tasks were designed.
Got it. Thank you very much for the answering. Sergey, what do you see as a common problem for the developers when they develop application that requires a lot of performance optimization? For example, you mostly see the same problem in the code. What is the most common problems people do in their development process that you every time do the same stuff to optimize the things?
It might be surprising, but I don't think there is a common theme for that, because in some cases, like in the past year, it's been like, okay, logger and that was creating stack trace, or logger that was writing to the console. So console is a global object, or reflection. or quadratic complexity based on link, because link was hiding that, or um, excessive access to the backend, like polling the backend every second from many machines, or excessive parallelism when we were oversubscribed in the box, or incorrect parallelism when you have essentially parallel for each and the first statement there is log. So it might be that's the deal. It might be almost anything. That's why if you care about perf, you need metrics to see the regressions, and you need to understand the tools to look into the code, what to look for. That's why I'm not a big fan of, oh, let's ban link, because first, link is very expressive and it might be very helpful, and probably in 99.9 cases it's gonna be okay. And if it's not okay, it still doesn't make sense to ban link, because you can have a custom link like implementation that it's gonna be as performant as the basic link. And the reason why it doesn't make sense to ban is because you can have so much stupid things in any place in the code anyways. So and link actually does have some specific patterns that you can look for and easily fix, because you can see that. And as I said, with like perf or excessive or redundant allocations as a proxy, you can see that. But if you have 4 nested loops and you have a horrible complexity, you won't see this in any profiler, and it might be not that easy to figure out. So that's why I'm not a big fan of rules. I'm not a big fan. So I'm more like a values principle type of person. So when you have a foundation like metrics, that you can have metrics dashboard, you can have anomaly detection if it does make sense. If you're a platform team, you probably need to invest into that more than others. But if you have a decent set of metrics and the tooling, that's probably enough to make sure that you can get very good results, instead of trying to force people and ban. There's some things that you can look at in pull requests, for instance. You can look for common patterns for like quadratic complexity, but it might be not that easy to see them. So that's my concern, that probably you won't see them and you would still miss, and it means that you still need these top level things that I mentioned, that like, yeah, you can look at them and probably should, but you still need to have tooling to figure that out anyway. So
Exactly. How about your advices? So, what does it take to become a performance expert?
So I would say that understanding the few levels of abstractions deeper is important. And there are like few things why it's important. First, it will allow you to make a better, so like, okay, so be more data driven, for sure, and don't jump into the conclusions too quickly, and understand the internals of the system, of the platform. I would say that this is a few things, and just be humble, and don't think that you know the answers, because it's okay to have theories, but explain them, express them, as especially as a more senior person, express them as theories, not facts, and be very explicit about that. And yeah, being humble and trying to understand the internals of the platform, of networking stack, of the stuff that you're dealing with. Use the tools to better to get better insights into this. That's probably the best course of action that I can think of.
How about your preferable books, maybe the tutorials to at least start to understand the performance stuff?
So this is not like, there are like a few books about .NET performance, They're quite good. I would suggest going through them. I can share the links. You can put them into the description. There are like few two authors in Pluralsight, actually. They're like really good. It's Bart Desmet and Sasha Goldstein. They have making performance faster, making performance, yeah, even faster. So this is like .NET Perf from the internals point of view. Matt Warren has a bunch of stuff about that. I have some decent amount in my dissecting the code blog in English. So in Russian it was mostly about like C# internals and the design, but not as much about perf. So right now I'm mostly writing about like perf specific internals, I would say. So it might be useful. Uh, yep. And there are a few talks that I've mentioned. Martin Thompson, I believe. This is a guy with a few talks about .NET. About actually, it's just that performance in general. It's not .NET. He's a Java guy, but it might be interesting to like see how like managed languages and perf and whatnot. That's what I would say. That's it. So again, something like even CLR via C# and Jeffrey Victor, it's gonna be the next guest. I guess. So that type of stuff is very useful. Not to be afraid to understand the next level. So a good book like that. C# in depth by John Skid. It's good, but it's not like perf specific. So I would say that right now it's and be conscious about a ton of advices right now on Twitter, on LinkedIn about what's better. Like, oh, Annie's link Annie is your enemy, and this is way better. So just you need to understand what's going on there. So I would say that when you're dealing with perf data and whatnot, you need to match that data with your inner understanding of this thing. That would what could build you the intuition about like, oh, something is off. That's a very, very nice thing. And don't get these facts. Try to see the actual underlying things between. So for instance, if you'll see that the next link method, like min and max, is like 1000x more efficient in .NET 8, don't remember that, because it's like, oh, okay, that's yet another API was moved to SSE or whatever vectorized way. Okay, maybe some others will come. That's like, why? It's not magic. It cannot be just purely 10,000x perf improvement for like just like why it's there. So that's an important thing to understand, why something is fast, why something is slow, why something you can or cannot use here. So just build this mental model and the context that would help you to transfer those facts into this mental model that you can apply at your job, where the situation is different, naturally different from all those specific cases that you can see in the wild.
Great advices. Yeah. Sounds really cool if you can apply this. If you start them.
You can. If just you probably like running a good tool and then figuring out, thinking it's not extremely hard. It's yeah. Go ahead.
As far as I remember, Bart Desmet's tutorial is a bit old. Yeah, it should be 2016, 15, I guess, but they are still relevant. Yeah.
I would say that again, you need to look at both Sasha Goldstein and Bart Desmet. They're the people who would try to give you the data backed by some reasoning. So you, again, by looking into what and whys, you will be able to say that, like,
Their
okay,
thinking
might
is
be off.
important.
Yes, it might be off in this version of the runtime, but the overall principles would be very useful. So I would say that I would always favor like timeless authors and timeless materials, like Mark Seaman with his awesome books about dependency injection in .NET. It's one of these good examples that yes, the tech might be off by something, but the principles that he's stating there, they are very timeless, and that's the indication of a good source or a good author. So that's what I would, and if you're given just facts, that's an indication of a not the right source that you want to follow. You should not be remembering facts. You should be you should be understanding what's going on there. You cannot remember all the facts there, and they can change, right?
How about the investigating the source codes? For example, if you say that, let's say the min max, do you sometimes need to look at the source code to understand how they implement it? Maybe you can find the reason why it is slow, or maybe you can wrap it up or build your own extension method or something else.
So I think it's a very, very deep topic, and one of the distinguishing factor of every good engineer I know is their ability to go deeply into the sources of, like, don't be they are not afraid of looking at someone else's code, debug like NuGet, whatever, and look at the BCL thing and whatnot. So this is an important skill that probably deserves another time. But in this case, it's simple, because if you see that it's slow, then you can try to see what other options are to solve this problem, because maybe the common thing is too abstract, too common, right? And you have a very specific information. So a very simple example might be, let's say that you're running on .NET 6 and you have a list. So .NET 8 added a ton of optimizations for list by getting the span out of it. But even on .NET 6, you can get the span out of it. So you can say that, like, okay, right now you would go, like, you can check that some specific thing is not super optimal and it's problematic for you, right? So it's on your hot path. And that's even when you stay on older versions. That's why it's important to know what's going on in the modern tech, and like, oh, I can do the same optimization manual right now. Put this into my helper, add a comment saying that please remove this after migrating to .NET 8. Probably you will forget that, but it's fine. But still, that might be a way to kind of use the same technique and fix that. And some people are so good in that they will actually find the problems in the common code, and they will go and file the PRs in for .NET, for the runtime, or for the common library. And yeah, so it is doable. It is definitely doable. It's way more complicated that you might think, because in that case, again, remember that you are talking about the library that is used by literally hundreds of millions of or billions of tools, and almost everything can matter there. Every extra if would matter there. For you, it's not. For them, it will. So that might make it more complex. But yes, figuring out how this specific thing works and looking into the source code and trying to understand that's whole. It's part of this framework of building this more solid mental model of what's going on at runtime, specifically for this specific application. Yeah.
It's great. So yeah, what do you think about people preparing to the interview processes, especially in terms of performance topics? does it really, let's say, make sense for them to at least understand basics to participate in all type of interviews? Or you think that maybe it depends from the business? For example, I saw a lot of businesses, the companies that ask performance questions, or I don't know, the algorithms, data structures questions, but they relatively don't need this type of topics. So what do you think about the knowledge from the performance perspective?
So, yeah, this is not a simple topic again. So, I would say that a practical, so fortunately or unfortunately, I would view the interview preparation process as a separate activity that has very little to do with your real knowledge and experience. So it's extremely rare that you would go through to the advanced data structure for actual perf analysis. So for perf fixes. So I would say that just separate them. Just separate these two processes. The hiring process is very dependent on the industry, on the location, and on the requirements for the specific company. And I would say that grinding lead code will not particularly make you a perf expert. This is a different skill. So I would separate that. I would not go with they are almost unrelated, I would say. But again, it doesn't mean that you should not go and grind lead code if you want to be hired by Thang or whatever right now with Microsoft there as well, and Thang or whatever. So yeah,
Definitely.
you would have to do that.
Definitely.
Probably not the answer that many people want to hear, but that's an unfortunate situation that I would prefer not to have lead code like things in interviews. But this is the reality, and this is the way they scale the hiring process. So
Nothing to do. Yeah, got it.
yeah.
So we have way more questions, but unfortunately we are out of time. So it is about 2 hours. We are talking, especially you are talking. So thank you very much, Sergey, for
Yeah,
the
of course.
clarification, for helping our audience to learn more about performance, to learn more about the topic they should take into account when dealing with performance. And I hope our session is going to be really helpful for people, especially wants to dive into details of .NET. It's not just about performance, but it is also about diving into internals of .NET. And I hope our audience will get a lot of information from our discussion. So thank you very much. It was my pleasure, really pleasure to host you, because you are my favorite author. I really love reading your blog, especially I follow you starting from 2013, about more than 10 years, and I'm really excited to learn about the architecture. And first I heard about Bertram Meyer and other famous people from your blog posts. So thank you very much. And special thanks for this book, Design Parents. And talking about Design Parents, are you planning to write something else, maybe about performance, or maybe the improved version of Design Parents in .NET? The last question.
Not right now. So right now I don't have any plans, but I can't say no. I won't say no, but it's something that I've been thinking since this book was published. But I don't have any specific plans. But maybe those discussions like we have right now will trigger that, and it's definitely possible.
Will be really helpful, because you're directly working all this performance stuff, and writing some book and seeing something from the real practitioner perspective will be helpful. I think if it is interesting
can
for
see
you,
that. Yeah, it's kind of like I was thinking to do something like again .NET performance patterns, essentially, again to follow the same thing when you have a specific use case that you might face, and then how to deal with this, and again go from that to more to principles, like to generalize from this specific case to more like to mindset it. Yeah, it's a good idea. It's obviously a good idea, but yeah, it's always about time and priorities and whatnot. Yeah.
And the last question, are you happy? Are you happy with .NET? Are you happy to diving into details of performance, or was there any need or thoughts about changing the language?
Okay, so yeah, I feel that .NET ecosystem, again, I've been in .NET ecosystem for like whole my for the entirety of my career, so obviously I'm biased. And the language itself, it's a ton of new things. It's like multi paradigm language, so you can use FP, you can use OP. The pace which like it is developed might be concerning and really fast for some, but it's quite nice, and it's a lot of new things. I'm happy with this thing. So one thing that is not always easy to, so the deeper your knowledge base, it's easier to transfer that to other domain to start, but to get the same level of depth is obviously not as simple. So yeah, but overall, I like my job. I like the stuff that I do right now with my team, with like focusing a lot on internals performance, mentoring people and working with people. So it's something that I've been really happy with, like just by interacting with others, inspiring others to learn, inspiring others to understand the depth and whatnot. And overall, I would say that doing the right thing and doing the right thing right. That's the two things that I'm mostly I love doing, like figuring out what's the right thing and then executing that thing correctly. So, but yeah, so I don't think that I have too much to say in terms of language. It's a bunch of stuff right now that is going on. I'm looking forward for discriminated unions for sure. That's one thing that I would say that will make my life day to day in day to day scenarios easier. So it would enhance the expressiveness of stuff and increase the amount of patterns that you can use, and more fully switch to more like functional pipelining, data massage and manipulation type of things. From that's I'm looking forward. Unfortunately, I think it was cut maybe in C#14, so we'll see. So that's the stuff that I'm looking forward for.
Yeah, I hope they will add this feature. So thank you very much, Sergey. It was really interesting, really excited discussion with you, and I hope we will have another session with you to talk about
I would love to.
Design, about parents, because I would be happy to talk with you about all this stuff. And maybe you may add, you should definitely add a lot of stuff to our audience, and discussing all these things, especially the design principles, patterns, will be really cool with you. So
yeah, we'll do absolutely.
Thank you very much.
Thanks so much.
Thank you, Sergey. Bye.
Bye.